The last thing we're going to look at for this chapter is absolute value inequalities, which is just, we're going to take everything you know about absolute value equations and everything you know about compound inequalities, and we're going to put it together. Because remember, when we were solving absolute value equations, we always were solving two equations, one for the positive answer and one for the negative answer. So now we're going to be solving two inequalities, one for the positive answer and one for the negative answer. So think about or consider the absolute value of x is less than or equal to 2. If we wanted to circle all the numbers that were possible solutions, that means we want numbers that are less than or equal to 2 spaces away from 0. Because remember, absolute value is just our distance from 0. So if I took these numbers and I turned them into a number line, and I looked at, okay, I was starting at 0, I have 1, 2, 3, 4, -1, -2, -3, -4. Absolute value tells me I want to be my distance from 0. Absolute value is my distance from 0. So since I want to be less than or equal to 2 spaces from 0, that means I can go to the right 2 spaces and I can go to the left 2 spaces. So since it's an equal to, I can also include my endpoints in my answer, which means -2, -1, 0, and 2. These would all be possible solutions. I can't use 3 or -3 because they're too far away from 0. So when I'm solving these, I'm always going to have to remember to solve for the positive answer and the negative answer. But when I solve for the negative answer, I have to flip the inequality to face the other way. So there's kind of a lot for you to remember here. Since there's a lot to remember, we're going to write the steps down before we solve anything, just so you can go back and look at them anytime you go to solve one of these. So the first thing you're always going to want to do is get the absolute value all by itself. So just like when we were solving equations and we needed the absolute value to be isolated, same thing goes for absolute value inequalities. We have to get that absolute value all by itself. Once we do that, we're going to write two equations, or two inequalities, I should say. The first inequality, we're going to leave exactly the way it was. We just won't put the absolute value bars in the inequality. Without absolute value. The second one, we're going to flip the inequality and make the answer negative. Once we write our two inequalities, then we're going to solve them both. And graph. So now another little trick to remember here is when you're solving these, if you're solving a less than or equal to, these are like solving and inequalities. If you're solving a greater than or equal to, these are your or inequalities. So their graphs are the ones that go out to the sides. the less than graphs are the ones that go in between. And you'll be able to see this once you start graphing your answers and looking at the actual solutions that you get. But just as a helpful hint, if anytime you see a less than sign, you should have an and graph at the end. Anytime you see a greater than sign, you should have an or graph at the end. So let's look at what this looks like with actual numbers. So let's look. The first one says we have the absolute value of x plus 7 is less than or equal to 2. I noticed right away that this absolute value is all by itself. There's nothing else going on here on the left side of the equation, so there's nothing else I have to move before I write my two equations. So I'm ready to start solving this. So the first thing I'm going to do here is I'm going to write my two equations. My first equation will be x plus 7 is less than or equal to 2. Stays exactly the same, I just take the absolute value bars away. My second equation is going to be x plus 7 is greater than or equal to negative 2. So super similar. The only difference is I flipped the inequality to face the other way, and I made that sign for the 2 negative. Then I'm just going to solve them both. So I'm going to subtract 7 here. When I do that, I'm going to end up with x is less than or equal to 2 minus 7 is negative 5. The x is by itself, so I'm done. I'm going to solve the other one. Subtract 7, subtract 7. When I do that, I end up with x is greater than or equal to negative 2 minus 7, negative 9. My x is all by itself there as well, so now I just have to graph my solution. So I know that my graph should look like an and since I started with a less than symbol. But just in case, I'm going to double check. I'm going to put my negative 9 down, my negative 5. I always put the smaller number first. They both get a closed circle. And then I'm going to look and say, okay, I want x to be less than or equal to negative 5. So I want to go this way from negative 5. And I want x to be greater than or equal to negative 9. So I do want all of the numbers in between. It's an easy way for me to check myself. And now I'm done. So now you try this one in your notebook. Once you've tried it in your notebook, come back, unpause the video, and check your solution. Alright, so first thing I look at and I say, alright, the absolute value is all by itself, so I don't have to move anything. So I'm going to rewrite my equation. I'm going to say, okay, I've got 8x minus 11 is less than 0. And as soon as I write that down, I kind of think to myself, wait a second, 0 is not positive or negative. So I can't flip it to have another solution. I also think about, can I be less than 0 spaces away from 0? That doesn't even make any sense, right? So this problem actually has no solution because there's no way I can be less than 0 numbers or 0 spaces away from 0. So anytime you have an absolute value inequality that wants you to be less than 0 spaces away from 0, there's no solution. Alright, so let's try and spice it up a little bit and solve something like the absolute value of c minus 1 is greater than or equal to 5. So I notice my absolute value is all by itself. I'm going to rewrite my two equations. So I'm going to get c minus 1 is greater than or equal to 5. And c minus 1 is less than or equal to negative 5. Then I have to add 1. I'm going to add 1 to both of them since I see that they're both the same. When I do that, I get C is greater than or equal to 5 plus 1 is 6, and C is less than or equal to negative 5 plus 1 is negative 4. And now I see that I started with a greater than or equal to sign, so that tells me that I should have an OR graph when I'm done, but I'm going to double check myself. I see they both have closed circles because they have equal to signs. Alright, and then I want C to be greater than 6, so I want C to go this way, and C to be less than negative 4. So I do have an OR graph because I'm pointing out for both of them. Just kind of reassures me that I solved this correctly. So you try the absolute value of 10 minus m is greater than or equal to negative 2. Once you've tried it in your notebook, unpause this video and come back and check yourself. So the first thing you did was rewrite for your two equations. Keep it exactly the same, and then flip it. So now, unlike absolute value equations, where we couldn't have a negative answer, they couldn't equal a negative number because absolute values always have to be positive, we can have absolute value inequalities that are farther than negative 2 spaces away from something. So it is okay for us to have solutions like this. So we're going to solve both of these, and we're going to say, okay, let's get rid of the 10 first. We're going to subtract 10, subtract 10. I'm going to do it right across because I know I'm going to take the same steps for both of these. Let's get rid of my 10s. Negative m is greater than or equal to negative 12, and negative m is less than or equal to 2 minus 10 is negative 8. Then I've got to get rid of the negative signs. When I do that, I have to remember to flip my inequality. So now I have m is less than or equal to 12, and m is greater than or equal to 8. Now I'm going to graph and see what happens. So I put down the 8 and the 12, and I want to put open or close circles on both of them. And I have m is greater than 8, so I'm going this way, and m is less than 12. But I know that I started with a greater than sign, so this is an OR problem, which means that once I start shading for an OR problem, I continue shading. So all of these are going to possibly be solutions. Let's try one more together. So this one, the first thing I notice is that the absolute value is not all by itself. So we're going to have to get rid of things and move things around before we can write our two equations. The first thing I notice is we've definitely got to get rid of this negative 1. Or this positive 1. So in order to do that, we're going to subtract 1. Which leaves us with 4. Absolute value of 2x minus 5 is greater than 20. And then we've got to divide by 4, which gives us absolute value of 2x minus 5 greater than 5. And now I can write my two equations and solve them. So now I can say, okay, I have 2x minus 5 is greater than 20. Oop, 20. Greater than 5. And 2x minus 5 is less than negative 5. So I'm going to add 5 to both of them. When I do that, I have 2x is greater than 10, and 2x is less than 0, and then I've got to divide by 2. And I get x is greater than 5, and x is less than 0, because remember 0 divided by anything is still 0. I want to graph this, so I'm going to put 0, 5, and then I see they both need open circles, and I want numbers less than 0 and greater than 5. And I look back and I check myself and I see, okay, originally this was a greater than problem, so I know it should be an OR graph, so this looks good. I'm done.